Now I'll start the Gazebo simulation tutorial. And my name is Lin, and you can call me Jack. Yeah. And I'll tell you some details about Gazebo. And first, I'll let you see my outline. I'll give some introduction and give some details of Gazebo and tell you how to use DRC simulation. And at last, I'll tell you where the reference is. And for the first part, introduction. Maybe you will think that why we have to use the simulation. Because if today you want to do a big scale test of maybe like Town, or maybe you want to test for your car running on the road, but sometimes you don't have even a big car. Like maybe Toyota, they want to try to use self-driving, but they have to buy a car. But if you use simulation, you don't even need to pay your money. You just need to build your own models, and you can put it into the simulation and do everything you want. And you can also build the environment you want. Like maybe today I want my car to running in maybe a gas stations or maybe running in school. You just build it. It's okay. And also, there is lots of open source on the website, and also a lot of source from Gazebo. There are maybe like some cameras or LiDAR sensors and lots of it. Like camera, you have stereo camera, RGB. And you can add sensors just what you want. Like I want to try the DocuBot with maybe a stereo camera. Then I just need to type some code, and I can put the camera on DocuBot and get some data what I want. Yeah. So maybe sometimes you will think like, I have my car now. I can do everything and get every data I want. But maybe to others, they want to do this in a big scale. They don't have money to buy it, and their professor won't give them money, so they just can use simulation. Yeah. And then, yes, you can see there's a lot of models in Gazebo, and like this is PR2. This one, yes, you can just do what you want inside. And now I'll tell you what is Gazebo. This is a well-designed simulator that you can maybe do like testing your algorithms or design your robots, and also add some physics inside, like weight, or maybe you can give it velocity and maybe acceleration, and you can get a lot of data from it. Like I get my camera image, or I get my maybe pulse or joint state. Yes, you can do everything you want. And also, you can test some AI system inside. Because just like the DARPA Robotic Challenge, they have Atlas models inside. And they write a lot of code of the Atlas joint or its sensors. And you can just get many data from the Atlas inside. And I'll tell about Atlas later. Yes, and this is a little environment I built in Gazebo. And this is just Atlas, yeah. And maybe you will ask me that there's a lot of simulator, but why we use Gazebo? The first one is we can import models from outside. Like if we build a model in SketchUp or maybe SolidWorks, and you can just transport the file and import it into Gazebo. But sometimes, because Gazebo's file type is SDF and DAE, model type is DAE, so maybe you have to transfer it. But if you want to do it, it's okay. Just do it. And also, you can get some physical data, like maybe today I need to test for my car to carry a 10 kg object, and maybe you can just add some code inside, like my car is carry a 10 kg object there and running around here and get some data from it. And also it is a good relationship with RVs. You can just run Gazebo and get some visualizations in RVs. Yes, and this is the models we import into Gazebo from document description. And Brian will give you some tutorials about document description next week. Yeah, and this is in document description before, and I imported into Gazebo. And this one, I just add some camera, and this is Dockybot. Yeah, I just add camera on it, and I visualize it outside. And this part, I'll tell you about Gazebo and RVs. The relationship between Gazebo and RVs is, today I use Gazebo, and I build my world and put my models inside. And I maybe get some data from the models. Then after that, I can use RVs to open the visualization software to see some visualization in it. Like maybe I can see the camera image, or maybe point cloud, or laser scans, point, whatever. Yeah, you can see like also like robot model. Yes, so sometimes you think that I only do simulations in Gazebo, and through the Gazebo I can get, maybe you can set up lots of physics or lots of models, but if you want to see the data, you can use RVs. Yes. Until this part, is there any questions? Okay, I'll continue. Yeah, and this is Gazebo and RVs. And now I'll tell some details about Gazebo. First, I'll talk about the GUI interface of Gazebo. This is on the upside part of Gazebo. And the first one is the mode you can choose. Select mode is just, you can click the project or the object or maybe the models you want. And translate mode is to move it. And rotate is for rotate, yeah. And scale mode is for changing the scale of the object. And the middle side is undo and redo. It's, you know it, yeah. And simple shapes is some simple shapes models in Gazebo. You can use it to build your own models, like maybe use one cube, or maybe with something you want to do, yeah. And also the lights. And here is some copy paste and align change view. You can try to use it later. And also it is screenshot here, and you can also record the log in Gazebo. Like your car running inside and you can log it. And after that you can play it. And on the downstairs there is some things like time, real time. Because this is a simulation. You maybe think that it is not in the real world. But in Gazebo it will let you maybe more familiar to the real world. So there is some time about in the real time, and also tell you the frame rate. Yeah. Is there any questions? Okay, I'll keep going. I'll tell about the file. There's two kinds of. One is world file, and another is model file. And world file is built from lots of models. You can just think it is a collection of robots and objects. And the robots and objects is the models you build or maybe you import from outside. And the format of the file is SDF. You can maybe search it in website. Yeah, it is a kind of files format. And you can save all models in a world file. And the model file is just model, yeah. And usually we use Gazebo, we use DAE in Gazebo to build a model. And maybe you can use SSCRO to put the DAE inside and use SDF to build a world by lots of models. It's okay. So yes, you just see that we can import from outside. Like maybe you use SketchUp to build your own models, or maybe SolidWorks. And now this is the first little tutorial, like building your own world. And everyone, you can just try it, but maybe there is some problems in VirtualBox because Gazebo is hard to run it. So by myself, I run it in a laptop, another laptop with Linux Ubuntu. And so maybe you will get some problems like lag or in the VirtualBox. But you can still try it to build a world yourself. Like this, I import these models, DuckyTown models and DuckyBot models inside. And I build a world like DuckyTown. And also, you can try to add some sensors on your own models. For example, I add a camera on DuckyBot models. And could you see this? Yes, it's a part of code, yes. And yes, because this camera is in Gazebo already, so I just need to include it from URI models cameras. And also then just change some like its joint to make it on the DuckyBot. And you can just use it and get some data. So is there any questions? Okay, and now I'll tell you the most important part, DARPA Robotic Challenge Stimulation. This is a package from DARPA Robotic Challenge. They have a package, their own package in Gazebo. And you can see this on the website of Gazebo. And also you can install it from Gazebo. It's okay, because it is open source. And first, I'll introduce the Atlas. This is, maybe lots of you have been seeing this before. Yes, it is a very expensive robot. So maybe sometimes if you just want use this to test in the real world, but when it is broken and you have to pay a lot of money too. So we just use simulations here. And first part, we can see that is lots of kind of Atlas here. And you can just Rust launch, because the DARPA Robotic Challenge, they have already write a lot of launch, including many kinds of Atlas. So you can just Rust launch it, maybe other types. And the first two, because this part is very lot of tutorials, so I separated to part 1 and part 2. And this is for part 1. This is Atlas keyboard teleoperation over Rust. Because there is a launch file in DRC simulations, and it is for teleoperate the Atlas from your laptop's keyboard. And you just need to launch this file, and there is an interface here. Yes, and you can use your keyboard to control the Atlas by maybe I is going forward and maybe going backward. And you can also edit the length or maybe the height for the Atlas. Like maybe I want to go forward for maybe 10 meters or maybe 5 meters. It's up to you. Yeah, you can just edit it. I have put this PowerPoint on the Google Drive. You can download it because I think maybe a lot of you couldn't see this. Yes, I put it in RV students file, and maybe you can download it later. Yes, and I'll just give some introduction here, and I'll give a demo later for the first part, and you can just listen, and I'll give lots of details later. Yeah. And the second part is you can do some visualizations in Gazebo and RVs. Just like maybe I launch the Atlas and I maybe I publish a laser scan message to it, and I can use RVs to see the laser scan and also get some feedback from the sensors. Yeah, and I'll show you later for this part. And also, there is this part is for like telling you that we can use ROS to control the atlas by by writing your own note, or maybe just write some code. And you can use ROS message to send to the atlas and publish it to him. Then maybe he will give some feedback from its sensors or what. Yeah. And in this example, I publish laser scan to it. And the laser scan's message type is STD message here, float. Yes. And this is yeah. Just you use your ROS node to publish your ROS message to Gazebo. And then Gazebo will get the message and maybe the sensors just get something feedback and it will send it back to the ROS node to let you know. And you can do later what you want to do. Okay, I'll try to use my words to let you know. Yes, first I ROS launch the atlas, DRC Gazebo atlas then launch. And then you'll see it is opening Gazebo now. Yeah, and you can see now, you can see atlas now. And then the first part, I'll first let you see the teleoperation from the keyboard. And I ROS launch the DRC Gazebo keyboard teleop launch here. And there is an interface here, down there. Just the picture I just let you see before. And now I type I, and it will start going forward. Yeah. And maybe you can do some change in the launch file here, like you can change, maybe you want the robot to go straight or go maybe left or right. And you just need to change some joints from here. Yes, and you can go back and try it later. Because there is an image and I have already installed the DRC simulation for you. And I'll upload it to the website. And now I'll let you see about the visualization from Atlas. Like now, I'll put an object here. Then I'll run the RVs here. Yes. And you can see, everybody have used RVs before, right? Yes, and you can maybe add something like, here I add some robot model inside. And also I add some maybe like camera here. And you can see, yeah, you can see what Atlas just see. And also, like adding a point cloud here. And you can see this is the point cloud. Yeah, the object in front of the Atlas, and you can see the point cloud here. And now I'll publish a laser scan to Atlas here, like by ROS topic publish. Then I add the laser scan in RVs. Wait, this one. Yes. So maybe you can just add something you want to see inside. Because like the image part, Atlas have two cameras here for the left side and the right side. And also lots of things like joint state, like maybe image. And there is a tools of ROS topic, like you can type ROS topic list. Then you will see the thing what Atlas now is publishing. Like maybe there's a lot of things here, and you can just type ROS topic list. And also you can type like ROS topic echo, and choose the one you want to see. Like maybe I want to see joint state. Then you will see the message it is typing here. It will run here, run by the ROS topic echo. And part 2, I'll tell you how to log the data in Gazebo and RVs. If you want to log some videos or some pictures in Gazebo, you can just use the GUI interface, user interface to take a log or maybe get a screenshot. And if you want to log RVs, and there is a tool named ROSback. Maybe lots of you have get used to using ROS and you know ROSback. And you can just ROSback record and save it to, maybe you can name it ROSback. Then after that, if you want to play the log, you can just use ROSback play. But before you using ROSback play, you have to get a ROS core, because you didn't have a master, so you can just use ROSback play. And from this part, I just write a launch file to play the log, so I don't need to type ROSback play. I just ROS launch this launch, and I can see the log on RVs. And this part is telling you how to use the Python. And you can maybe write some code with Python in ROS and control the Atlas by ROS. Like I write a Python node here, a ROS node here with Python, and I can change the joint state of the Atlas. I'll give some introduction of joint state. Like every robot, they have each joint. And when you give the joint state, and like now I give my joint for maybe XYZ for this part, and I give it, he will try to go to there by the forward kinematics. Does all of you know the robotics? Forward kinematics, yes, and it will go to there, yeah. So this part, I just only need to publish a joint state to Atlas, and it will try to move its arm or maybe its leg. And this part there is a parameters file for YML here. Yes, and I'll first tell you what this is. For the first, this is the durations. Like maybe I want it to do maybe 10 seconds or 5 seconds. And the second part is the Atlas neck and its body. And this is the position of it. Like this first part, there is 4, 2 for neck and 2 for the body. It's X and Y, because it can move Z. But your neck cannot go up. Yes, and so it only give it X and Y, and also the body for X and Y. And this 4 part is left arm, and left leg, right leg. And each leg and arm there is 2 joints. So for the first joint, it will give it XYZ, and the second joint, it will give it XYZ. So just like this, you want your robot to maybe move their hand to where, and you can just give it its YML to change the parameters. Like I want to give my robot to go to maybe 1, 1, 1, and you just type it inside and it will run to here. Yes, and I'll give demos from here. Yes, for this one you can see this YML here. And I just add a step here. And you can see now I type. The Rust launch, I open the Gazebo for Atlas and I change it to, I type the Rust topic publish Atlas control mode to change it to user mode so that I can control it. Now I change it and then I just need to read the Python code here. Like I give it step and fall. Wait. But for this part, I just let the Atlas to move its arm. And now I give it step. And he will raise his hand. And so if you want to get some change for it, you just need to maybe get some change in parameters in YML. Like you want to let it moving its leg, or maybe like I want it to fall down now. Then I just need to type touchdown. Here I give it touchdown. And you'll see it's doing something like I just send it in the parameters. Yeah, so you can control the Atlas by changing the joy state by yourself. It's 40 now. Yeah, okay. I'll give the conclusion here. For that, because I have do a part let Atlas in our Ducktown and see some lines in Ducktown. And first I import our Ducktown inside. And I just import it to here. So I can just click, maybe I click here for our models and I can put it inside here. And you can just, there's lots of open source from here, like maybe you can put like, you can put a cafe here. Or maybe you can put anything you want here by importing your own models. And now I'll let Atlas stand on Ducktown. Yes, and now use Rust RVs. Yes, and I'll let you see the camera here, and also the point cloud here. Yes, and you can see, yeah, the point cloud just gets some. It's not clear here, but there's white and red and blue and yellow on the point cloud. So you can just do something you want in simulations. And you can use RVs to get some data, or maybe log data. And maybe you can also write a Rust node to get some message from Gazebo or from RVs and do something you want.